latent variables can be thought of as an extension of true score theory from classical test theory, but a somewhat misforgotten or ill talked about idea is like, what does it mean for to be modeling latent variables or true scores? So that's what we're going to talk about today, is how can we define and think about what a true score is, and then how that then relates to latent variables such as factors in factor analysis. So to start, in classical test theory, one of the things we do is we decompose an observed score x into the true score plus error. So we can think of that as observed is composed of what we would like a something under in some type of truth and error. However, a problem with thinking about it like this is truth doesn't necessarily mean what we think it does. And how do we define what truth is? That's a very difficult idea and concept. But in classical test theory, we have to kind of wrap our minds around what does it mean for something to be true. One of the ways that we conceptualize it is the truth is just the expected value of our observed score. So now what does that mean? Thinking about expected value. Expected over what? That is the fundamental key part of thinking about true scores and latent variables, is how can we think about expected? Well, again, the question we need to ask is expected over what? And that is how we then will go about relating it to latent variables as well. So within classical test theory, this fundamental assumption of thinking about how does the true score relate to our observed is through expectation, but how we come about that is really based on a hypothetical experiment. And the hypothetical experiment requires mind wiping, and repeated administration of x, whatever x is. And so we can think of, so what the expectation would be, what would we observe if we could give an assessment 100 times? Then the true score would just be the average of those 100 scores. However, we can't do that typically. Most people would remember their answers to questions, and so that falls by the wayside. Another way of thinking about it is, what is the expected value for people that have the same level of the trait? And so what that kind of gets us thinking about is strata of people in the population. And so that's one of the powerful parts of thinking about classical test theory, is trying to link between our unobserved t and x. How do we link these two? And that is where we start thinking about latent variables as well. We can actually not only think about it x as a whole test, but then breaking it up by the items. So thinking about expectation . over items. And so that's a really powerful part of latent variable modeling is we can move from a whole test to thinking about things at the item level. And so one of the ways we can redefine our latent variable is our latent variable t, typically also written as theta or eta, depending upon whether you're in classical test theory, item response theory, or in factor analysis world. These are the types of notation you might come across. But when we really think about these two, thinking about true scores or unknown scores in factor analysis or IRT, we can really start to decompose them, not with just respect to the whole test, but at the item level. And so we can think about our vector of item scores is then related to the unknown scores that someone has on the latent variable based on some matrix or some mapping between the two plus error. And then this is the kind of fundamental equation of exploratory factor analysis. And this also can be equated in IRT by just thinking about x is some function of your latent variables. And then that the error function gets dealt with depending upon what that function is. And so there's lots of powerful ways of thinking about these scores depending on if you're an IRT or factor analysis. But we'll talk about that probably some other time. But the idea is thinking about, well, what do we mean about this latent variable? What does that represent? And so in factor analysis, we can really start to think about the latent variable as either a common variable across all measurements of x. So if x is just a vector of x1, x2, xp, so you got p variables, and we can think of, again, this factor loading matrix, and if we only have one eta, then you got error scores as well. We can think of eta as the expectation over x. If eta is the expected value over x, we can start to think about it, well, maybe it's not a direct expectation. Maybe it's a weighted expectation, depending upon how strongly each item is related to it. And that's where the kind of lambda comes in, the factor loadings. We can then weight the expectation based on those values. And so that is one way of thinking about latent variables, is some type of composite of the observed scores, but there's also this error component that makes it so that a direct composite is probably not what we were expecting. And so thinking about it as this idea as well, maybe we don't want to think about it as a direct weighting of items, but that there is some underlying state or value that people will take on. So there's all these different ways of conceptualizing it that can be very powerful. But I think underneath a lot of these different ways of conceptualizing latent variables and true scores is to think about it as, what are we taking an expectation over? Is it over all the sets of items, maybe weighted by something, or are we thinking about it in terms of some type of mind-wiping experiment or repeated administrations of the same items in the same test? So these are the different ways that I think are really important to think about it. And maybe it is some combination of the both that you and your application need to think about it. But I think in general, we can do a very good job of thinking about what what way of thinking about our latent variable is best suited for the application that we're working on here. Because in educational settings, I think it does really make a lot of sense to either thinking about it as some type of un, re, concept under repeated administration. That can be a really useful idea. But in a lot of psychological constructs, that might not really be the case because we might want to think about a construct as a composite of specific items. And so these different conceptualizations can be really important, but and distinctions can be important as well. Thank you, and look forward to any questions you might have. Have a great day.